EZ3DBiz.com here, giving you an update on our research. As you know from the previous research we had done, basically this was the older model, and quite simply the problem we had here was the drying out here. This would dry out really quickly, and it wasn't just the drying out, it was the moisture that would attack the magnesium. This one's been dry for about a week right now, and as you'll see on the voltage right here, we'll go ahead and connect the voltage up. After about a week, it is starting to dry out, so the voltage is dropping. I'll go and connect the leads right here. But it still has power, even though it's been about a week. It's only yielding me about a volt, just under a volt. And so what I did was I improved the design. I got rid of the Elmers Glue, so there's no more Elmers Glue. And then what I did was I made a bunch of prototypes right here. Basically, I just have a standard copper pipe. And then around here I have a formula of special ingredients. Basically I made 4 prototypes right here, and I picked the one that didn't have that didn't corrode the magnesium. And out of all the 4 prototypes, this was the one that had the best results and did not corrode the magnesium. This is pretty solid. It's dry. See? This is pretty much completely dry. The only rubber sound or rubber feeling is from the sodium alginate, which is good because the rubbery keeps the texture in right there. So what I'm going to do right now is go ahead and do a test on this. Go ahead and put the voltmeter right here. And I'll connect the leads up. Put one lead right here. And I have a piece of magnesium right here. So we'll go ahead and test it. Just run it across like this. It's a comfortable, constant about 1.43, 1.42 volts. And this is good because this is a dry surface. Now because this surface is completely dry, that means we have no problem of this corrosion that was happening here from the magnesium because it's not damp. Because this is totally dry, that means we have lots of voltage, but we have no corrosion for the magnesium. And that's a very, very good thing. Because that means all we need to do is just basically wrap the magnesium around here, seal it up, and that's it. It's running just off of this basic connection and these ingredients. Now, out of all of these, I discovered that the darker colors, these were the darker prototypes, these were the ones that corrode the magnesium the most. Even though this one had pyrite in here, this one had galena, this one had limonite, which is a form of oxide. This has none of those. So it not only is very easy to work with, it dries nice and hard, it's solid. You can bang it around like this. See? It's totally solid, and it still yields a constant voltage. It's pretty fun, pretty amazing. And I'll go ahead and show you the magnesium test strips on here. And when I was using these dark ones, this is what the magnesium would look like as far as the corrosion will go. I don't know if you guys can see that. But there's a little bit of corrosion on here from using the dark ones. As you can see, I got the test strips already embedded in here, and I just pulled the test strips out to test them after about 5 days. Now this is the magnesium from this piece right here. As you can see, there's almost no corrosion in here at all. And this piece was embedded inside, as you can see right here. You can see the chip right there. This was put in here for about 5 days. So there's almost no corrosion whatsoever. So that's pretty amazing. And I find it quite interesting because all you need to do now is basically wrap your magnesium around here, no corrosion. Connect your leads up like this, and voila, you got voltage with no corrosion, which is pretty cool. The main discovery and the main breakthrough of all this was basically using potassium chloride. I'll go ahead and find the potassium chloride here. Basically also known as salt substitute or new salt. And what happens is when this dries, it creates a very fine crystalline structure right here at the end, which becomes very conductive, and also it absorbs moisture just enough in the air to conduct without corroding the magnesium. It's a pretty interesting breakthrough. And the majority on this is potassium chloride. Now in my next video, I'm going to go ahead and reveal the formula I've used with this one, and I'm going to reveal the formula of the new prototypes I've made that's even more resistant to corrosion, and it's probably going to be the final formula because it's so effective. So go ahead and stand by for my next video. Thank you for watching. Wish you all continued luck in your zero-point energy research.